Hi everyone, so in this video I'm going to teach you all chipsets of a computer, including the processor, the NOT bridge, the ICH, the graphic card, the Super I/O, etc. Okay, so let's get started. Let's begin with the processor. So basically, as you can see here, we have the processor. We called it processor or CPU, okay, or central processing unit. Okay, so let's first see the definition of the processor. As you can see here, a processor or a microprocessor is a small chip that resides in the motherboard. Okay, the processor of a computer is also known as the CPU or central processing unit. It performs controlling. Okay, so after the definition, I'm going to analyze with you the processor schematics, and we're gonna speak about the processor power, etc. Okay, so the processor performs controlling basic arithmetic, logic, and input-output operations, okay, as well as giving control commands for other chips and components running on a computer. Processors can handle trillions of calculations per second. It is seen as the main chip in a computer. Okay, so here we have seen that the processor gives the control commands to all chipsets in the motherboard. Okay, so here, as you can see, this is a picture for a processor. This is basically a basic processor. Okay, you can find a very improved and enhanced processor, and of course you can find just a normal processor. Okay, like dual core, etc. So basically, this is one part of processor pinout, as you can see here. So inside the processor, you're gonna find many controllers. Okay. Sorry. So each part here means a control. So inside the processor, it is divided into many controllers, including, for example, power, including control, etc. For example, here we have, as you can see, the clock. You know, the clock or the timer. Here we have this controller. Okay, so this rectangular here means a controller. So this controller inside the processor is responsible for temperature. It controls the temperature. For example, if the temperature of the processor is increased, it will send a control signal to the fan to speed up in order to cool down the processor. Okay, here basically we have the XDP, ATP signals. Okay, here we have control signals. In this control, we have control signals, including enables, etc. Here we have address group 0, address group 1, etc. So this is just one part of processor. Of course, you're gonna find other controls like the power controller, okay, the logic controller, okay, the arithmetic controller, etc. Okay, so basically the power for the CPU, we called it plus VCC core. Okay, plus VCC core. Okay, and plus VCC core for CPUs is usually equal between 0.7 volt DC and 1.3 volts. Okay, and here of course all those are pinouts. Okay, so let's see right now the next component. So the GMCH or control memory graphic hub. Sometimes we call it GMCH, sometimes NOT bridge, okay, or NOT bridge. As you can see here, we're gonna also discuss the circuit pinout, but let's see first the definition. So a NOT bridge is an integrated circuit. Always IC means integrated circuit that is connected directly to the CPU. So basically this chipset is connected directly to the CPU, okay, using a bus. We call that bus the FSB or front side bus. Okay, so the NOT bridge is the intermediate between the CPU and other components in the motherboard. Okay, so it is connected directly to the CPU via the front side bus or FSB, as you can see. It is responsible for tasks that require the highest performance. For example, memory and graphic or display operations. Okay, so responsible for tasks that require the highest performance. That's why it is associated with the fastest component in the motherboard. Okay, the fastest component in the motherboard is what? Is the RAM and the graphic controller and source bridge, as you can see here, including RAM, random access memory, graphic card controller, source bridge or ICH, input output controller hub, as well as the CPU, of course. So this one, the GMCH is connected with the CPU in one side and with the graphic card and with the ICH. It manages communications between the CPU and other parts of the motherboard through different buses. Okay, so as I told you before, the bus that connects between the GMCH and the CPU is, we called it FSB or front side bus, and the bus that connects between the NOT bridge and the ICH or the source bridge, we called it DMI or direct media interface. And also the bus that connects between the GMCH or the NOT bridge and the RAM random access memory, we called it RAM bus or DDR maxing. Okay, and so on. So basically here also the same working principle. This is just a part of this NOT bridge. Inside this NOT bridge you're gonna find many controls, as you can see, including this controller that is responsible for controlling the exchange of signals between the NOT bridge and the source bridge. As you can see, this is a bus, direct media interface. DMI means direct media interface. So basically this bus connect between NOT bridge and ICH. We have here clock or timing. We have here DDR maxing, also this control the signals between RAMs and NOT bridge. We have here, this is basically reserved, CFG, PM or power management. Here is for power management, as you can see we have power or key. Okay, this is MISC. Okay, here we have NC means no connection or not connected. Basically all these pins are not connected, but we call this a growth. You could use this in order to make, for example, the GMCH enhanced GMCH. Okay, so let's see the next components. So then here, as you can see, we have the ICH. This is one of the most important chipset in the motherboard. Why? Because this chipset is the chipset that controls all ports and connectors in the motherboard, including also the keyboard, the BIOS, the mouse or the touchpad, etc. So all ports in the motherboard. If you have a problem, for example, that the ports are not working, it's not mean that the ports are failed. No, this chipset are failed. This chipset basically controls all ports in the motherboard. As you can see here, USB ports, SPI, this is a BIOS, direct media interface. This is the bus that connects this chipset to the NOT bridge, or the PCI Express, etc. So let's see the definition first and then go ahead and analyze this circuit. So a source bridge is a small chip that resides in the motherboard. It is connected directly to the NOT bridge, okay? Via what? Via DMI, direct media interface bus. It connects the NOT bridge to other components inside the computer, including hard drives. So This basically ICH control hard drives, BIOS, network connections, USB connectors, sound cards, HDMI, okay, the system clock, etc. The sort bridge basically sends and receives data from the processor through, okay, so it receives data and control signal from the processor, but through the NOT bridge, because the NOT bridge is the chipset that is connected directly to the processor. Okay, so sort bridge is also referred to as the input-output control hub. That's why we called it ICH, input-output control hub, since it controls the inputs and output devices. Okay, so as I told you before, if, for example, if you have a bad ICH, automatically all parts in the motherboard will stop working, and of course the keyboard, the mouse or the touchpad, the BIOS, etc. And of course, if the BIOS is stop working, nothing will happen in the computer, because the BIOS is the first IC that controls the booting up of the computer by the program inside it or the software inside it. Okay, so basically here we have each circuit, the same working principle. This rectangles means controllers inside this ICH. This is just one part. Basically we have 4 parts like this one. Just as example, here we have, this is a controller that controls USB connectors. Okay, this is a SPI or BIOS. Here we have PCI Express. Basically PCI Express are connectors that we can use to add more external cards in the computer motherboard, including, for example, USB cards, for example, network cards, etc. Okay, and over here we have DMI or direct media interface controller. Okay, so let's see the next component. Then we have the RAM or random access memory. Of course, this also is one of the most important components. Why? Because without this chip or RAM, nothing will be displayed in the screen. Okay, without RAM, nothing will be displayed. Okay, so RAM basically, or random access memory, contain many chips, many RAM chip inside it, as you can see. And of course there is many types of RAM: DDR1, DDR2, DDR3, DDR4, DDR5, etc. Okay, so basically the RAM power is not the same. So for example, the power for DDR1 is 2.5 volt. The power for DDR2 is 1.8 volt. And the power for DDR3 is 1.5 volt. The power for DDR4 is 1.2 volt. And finally, the power for DDR5, one of the most and enhanced RAM, is 1.1 volt. And of course, for the RAM, it don't has just one power. It needs 2 kinds of power. One main power and the VDD, or the power for terminals. The power for terminals is always the half of the main voltage. For example, for DDR2, for example, the main power is 1.8 volt and the VDD is 0.9 volt. Okay, for DDR3, for example, the main power is 1.5 volt and the power for VDD is 0.75 volt. Okay, so let's see the definition first. Random access memory, RAM, is a type of a data storage used in computer motherboards. This type of memory is volatile. Means what? Means if you remove the power, the storage will be lost. Okay, and all information that was stored in it is lost when the computer turns off. When a device has sufficient RAM, several programs can run simultaneously without any shutdown. The RAM is connected directly to the NOT bridge via memory bus. Of course, the RAM is connected to the NOT bridge. That's why we called it GMM, means memory, graphic memory, GMCH, graphic memory controller hub. So it controls the graphic and the memory, but when the graphic is integrated in the NOT bridge, we called it GMCH. But if the graphic is separated, we called it just MCH, means memory control hub. Okay? So let's see the next component. Basically here, this is the pinout, just one part of the RAM circuit. Okay? The same working principle. So then we have here one also of the most important circuit or IC in the motherboard. Why? Because also this IC is the responsible for the whole power in the motherboard. Without this IC, nothing will be powered on. So let's see the definition first. Super input outputs I/O, or we called it SIO, is an integrated circuit on a computer motherboard that handles and manages slower input-output devices like keyboard, mouse, power port, RTC real-time clock, serial port, infrared temperature sensor, and fan speed. So you can here observe that we have here keyboard and mouse. And of course, this one controls or manages the keyboard and the mouse, and also the ICH controls the keyboard and mouse. Basically, the SIO, the ICH, and the BIOS are always work together. You will find always in the motherboard this IC, the SIO, next to the ICH and next to the BIOS. Okay, so basically this is the pinouts of this IC. We have, as you can see, a lot of pins where we have enable, clock, etc. Here we have U1013. This is its reference in the motherboard, and here we have its reference designator. For example, if you have a bad SIO, you can use another one with the same reference. So let's see the next component. Then the BIOS, as you can see, the basic input-output system. Also, this is one of the most important ICs in the motherboard. Why? Because without the BIOS, the laptop or computer cannot boot up, cannot turn on. Why? Because the BIOS contains a program or a flash or a software inside it. If the software is corrupted, the operating system can never be downloaded. Okay, so let's see the definition. The BIOS, basic input-output system, is an essential component in the computer, allows the CPU to communicate with connected inputs and output devices. When the computer is powered on, the BIOS will perform many tasks such as CPU test, CMOS configuration check, initialize the timer, RAM and cache memory check. It checks all the configurations, keyboard, mouse, monitor, hard disk, etc. If everything is okay, the BIOS loads the operating system into the computer's memory and finish the boot up. Okay, so basically here we have the BIOS circuit where we have 8 pins. Basically you will find in recent motherboards, and always usually 80% of motherboards contain this kind of BIOS, a BIOS with 8 pins. So above the BIOS, you will usually find a pin like this one, marked BIOS. Here we have this dot here, means the pin number 1. Okay, this dot here means we have pin number 1, pin number 2, number 3, and pin number 4, always connected to the ground, as you can see here. So pin number 4 of the BIOS is always connected to the ground, as you can see. We have here VCC. So if you focus here in this image, here we have path, a thin path, because here we have signals, and this one we have no path here, means here we have ground, because this is the pin number 4. Okay, so pin number 5, pin number 6, this pin is always connected to what? To the clock. As you can see, we have pin number 7 halt, and pin number 8 we have VDD. As you can see, VDD 3.3 volt. Do you observe here? We have a little bit of bolded line, means we have power. Okay, here we have a thin lines, as you can see, because those 3 are just signals, control signals: enable, write, protect, etc. So output. And here where we have power, we have a bolded line, 3.3 volts. Okay, so always for the BIOS, if you check the pin number 8 here, the VDD, you will find 3.3 volt without powering on the computer or the laptop. Okay, if you find 3.3 volt here, means all powers in the computer are good. So thank you very much. I hope that you enjoyed the video. Please don't forget to like the video if you enjoy it, of course. Share and subscribe for people that are not subscribed yet for coming videos. And for anyone who want to join me in the Patreon page, you are very welcome, guys. Thank you very much, and see you in the next video.